Okay, class, welcome to our next math lesson. We are still in Module 2 of Eureka Math. This is Module 2, Lesson 5. And Lesson 5 is about the third type of rigid motion, rotations. And you will need pages 43 through 53 in your Module 2 books. You also might need a ruler. You will probably need your transparency to help with the transformations. You will need a piece of paper for notes. You will need pens or pencils to take notes. You also might need one of these little things called a protractor because we are talking about rotating, and rotating uses angles. So when you have your materials, you can get the video going and we can start taking the notes. So the road so far, what have we done so far in Module 2? Well, we learned that there are three types of what we call rigid motions. Now, rigid motions are transformations. They are changes where size and shape stay the same. Changes that keep congruence. Remember, congruence means same size, same shape. So rigid motions, rigid means firm, rigid means hard. So the shape and the size are firm. Shape and size are solid. Shape and size stay the same. Changes where shape and size stay the same. So the three types of rigid motions, the first one we learned about, we called a slide, but then we came up with the better word, translation. When we slide a shape, we translate it. And the rule for slides, for translation, is a vector that tells us direction and distance. The next type of rigid motion we studied was called a flip. The more technical mathematical term is a reflection, like looking at something in a mirror. And the rule for a flip was not a vector. The rule for the flip was a line of reflection. So for a slide, we need a vector. For a flip, we need a line of reflection. Today, we're going to talk about the third one, the spin. That is today's work. Now, a spin, we're not going to call it a spin. We're actually going to call it, and you probably guessed it from the name of the lesson, we're going to call it a rotation. Rotation is the technical word for a spin. So that's what we're talking about today. And for a spin, we do not use a vector for a spin. We do not use a line of reflection for a spin. For a spin, the rule is we need a point and we need a number of degrees. So we need a point and a number of degrees. So this is what we're focusing on today. The spin, the rotations that need a point and a number of degrees. Let's talk about these rules a little bit more. The rules for how to rotate. The first thing you need, like I said, you need a point. You need a point to spin around, which is how spinning works. You spin around a point. So like if you're spinning on your foot, you're spinning around your foot. Your foot stays on the ground in the same spot and everything else spins. If you have a spinning desk chair, you can spin on the chair, but the chair stays in the same place. You just spin around it. Or if you've ever tied a rope, or like if you have tied something to a string, and spin it around with your hand. Your hand stays in the same place, but it spins around your hand. Think of like a yo-yo, or if you have played tetherball in school, the tetherball spins around the pole stays in the same place, and the tetherball spins around it. So the point is what we spin around. So if something is going to spin, the first question is, what is it spinning around? That's the first question. What is it spinning around? The next thing you need to know how many degrees. Oh, I was going to do degrees in a different color. How many degrees will it spin? In other words, how much spin? So you need a point to spin around, and you need to know how much will it spin. We need to know how much will it spin. So what is it spinning and how much? So let's look a little bit more about the degrees, because a point is just a spot. This one is just a spot. The degrees might be a little bit trickier. Let's show you how degrees works. When you rotate, the shape that you rotate in, you don't rotate in a triangle, you don't spin in a square, you don't spin in a pentagon, you spin in a circle. We rotate in a circle. Now, a circle has 360 degrees. Why did they pick 360? I'm not exactly sure. It probably has something to do with the ease of math. It probably has something to do with history and the people who just like those numbers. But a circle has 360 degrees. Let me show you how. Let me draw a circle, or the best circle that I can draw. That's not bad. Let's pretend that's a perfect circle. So this is our circle, and let me show you how they measure degrees. So to start with, we start with the center of the circle, and we have a line right here. Right here is 0 degrees. It did not move. And then, but let's say it starts to spin, going around the circle. Let's look at the top. Let's go straight up like a clock. Let's go to the left, and let's go down from the center. Now, when we follow the circle up here, when we go around the circle up here, the blue mark, the blue going straight up, 1/4 of a circle is 90 degrees. You know this is true because if you look right here, you've studied angles before in triangles. You know this makes an L shape. This is 90. An L shape, you know, is 90 degrees. So a circle that follows one L shape is a 90 degrees of the circle. Let's say we move down to another 90 degrees. Another L shape. That's 90 degrees for this part, 90 degrees for this part. So that's 180 degrees in total. So if we start here and spin all the way around, that's a 180 degree spin. Now, you might know this if you skateboard or snowboard or you watch extreme sports where people do this. If someone is going in one direction and then they spin to go the opposite direction, you know they did a 180. It is common language for skateboarders. This is a 180. You go this way, then you spin, you go the opposite, that's a 180. Let's say you go another 90 degrees. So we go one L shape to be 90. We follow the circle, another L shape to be 180. Then we follow it another L shape for another 90. Well, 90, 90, 90 makes 270 degrees. So we go around the circle and we just add more degrees. What happens if we keep going and we go all the way back to where we started? We do one spin all the way around. We add another 90. Well, if we spin all the way around, how many degrees did we turn? We turned 360 degrees. That's why in skateboarding and snowboarding, when someone does a full turn, it's a 360. If someone does 2 full turns, it's a 720 because that's 360 and 360. You've probably heard these terms before if you skateboard or snowboard, or even if you do gymnastics. So that is how degrees work. Now you notice degrees get higher going this way. This is a little bit opposite from what we're used to. Normally on a clock will spin this way. But degrees work opposite. Degrees count this way. It's called counterclockwise. So because degrees count this way, that is called counterclockwise. And that makes positive degrees because that's how they count. Because degrees go this way, if it's positive, we spin this way. So if you have a 90-degree positive spin, you go up here. But you can also spin the other way if you really want to. You can spin that way like a clock. That is called clockwise. But if you are spinning this way, because you can spin whatever direction you want. But if you spin counterclockwise, that's positive degrees. If you spin clockwise, that's negative degrees. Very important to know if it's positive or negative so you know the direction of the spin. So for spinning, let's talk about what you need. You need a point to spin around, which if you're talking about a circle is the center of the spin. The point is the center of the spin right here. And you need to know how many degrees. Are you going to go 90 and spin this way 90? Are you going to go 180 and spin that way 180? Or are you going to go negative degrees? Are you going to go negative 90 degrees and you start at 0 and you go the opposite? You count this way. So that will take a little bit of practice. It will take some testing to understand fully, but that's why we're here today. Make sure you have it written down in your notes because having it in your notes will help you learn it, will help you remember it. So let's practice some of this. Look at page 43 of your notes, please. 43 of your textbook. Page 43 of your math book to test some examples. Make sure you're looking at your notes. Make sure you're using your notes. Make sure you have the notes copied down. If you missed anything in the notes, rewind the video and try and make sure you get what you need. Your job is to get the notes down. Your job is to study your notes. Your job is to use the notes to help you. But I will, of course, help you with the exercise right now. So let's start with exercise 1 on page 43. It says, let there be a rotation of d degrees. So how many degrees? They don't tell us. They just say d, which means we can pick whatever rotation we want. Let around center O. So O is the center, and we're going d degrees. Now P is a point other than O. Select D so that D is greater or equal to 0, which means D has to be bigger than 0. So we need a positive spin. So D is greater than 0, which means D has to be positive, which means we are spinning this way. Make sure you write down which way you're going to spin. You know that D has to be greater than 0, so D is positive, and a positive spin goes that way because it's in your notes. And then it says find P prime. So we're going to spin P around O. So let us do this. So what I'm going to do first is I'm going to trace everything on my transparency. You can see my transparency kind of right there. It's kind of a little bit shiny. I'm going to pick O, the center. I'm going to label P. And I am going to label the bar connecting them, the ray connecting them, so that I make sure I stay the same distance away. And then what I need to do is I'm going to spin it this way. So I get to pick how far. I get to pick the number of degrees. I don't need to measure it. I just need to make sure it's positive. So remember, the center is O. So O is the center. O never changes. So I can go there if I want. Now, you don't have to go there. You can go here. You can go here. You can go really anywhere. P can be anywhere as long as it is a rotation. So I'm going to stop right there, and I'm going to take my pen. I'm going to sneak under the transparency, and I'm going to put a dot right here, and that is my P prime. Because I rotated around O. How many degrees? I don't know. It doesn't really matter how many degrees I moved. But that is where it ends up. That's how we rotate. That's how we spin. The center stays in the center, and everything else spins around the center. Okay, let's look at number 2. More practice. Let there be a rotation of D degrees. Again, it does not tell us how many. It just says D degrees around center O. So O is the center again. Only this time, select D so that D is less than 0, which means this time D is negative, which means the spin, check your notes, the spin has to go that way. So let's try this again. Let's do it this way. Let me trace the center O, my point P, and let me trace the ray connecting them, and then I'm ready to rotate. Now the center O, so the O is going to stay in the same place. And which way am I going to spin? Well, I know D is negative, so I have to spin this way. So O stays in the same place, and everything else spins. So P, I'm just going to stop right here. You can stop wherever you want. But I'm going to put P right here. That's my P prime. There we go. I rotated it that much. And so hopefully you're following exactly what I do with the transparency so you can see what the rotation looks like. Before the rotation, after the rotation, and during the rotation. It is good practice. So take your time and use your transparency well. Let's go to the next page and see what other practice we can do with exercise 3. Oh, here we go. What direction did P rotate when D was greater than 0? Well, we know that when D is greater than 0, D has to be positive, which means it goes that way. And that direction is called counterclockwise. For number 4, what about when D is less than 0? When D is less than 0, we know D is negative. And in our notes, we know a negative rotation spins like that direction, which we call clockwise. Write these things down. Think about them a lot. Always look at your notes for this until you internalize the information. That means until you have the information memorized and you know which way to spin things. It can be a little bit tricky before you know which way to spin things. But that's why we're practicing. That's why you have your notes in front of you. That's why I'm here to help. Now, number 5 is going to be a little bit more fun. It says let L be a line. Here it is. AB be a ray. Here we go. CD is a segment. Right here. Angle EFG is an angle, like right here, EFG. And let there be a rotation of D degrees. So we can pick the number. Around point O. So point O is our center. So here's point O down here near the bottom of the page. Find the images of all figures when D is greater than 0. So which means D is going to be positive, which means you know in your notes that we are spinning that way. So we need to do a lot of work here, but that's okay. We can do this. It's not so much work. It's more like a puzzle. I look at it as kind of a fun little challenge, a fun little puzzle. If you come into it looking at it positively, you're going to have a much more fun time than if you are negative and you think about how much work this is. Right now, just think of how positive this is, how fun this can be, and you'll enjoy this a lot more. So let's trace everything so that we can rotate it. So there I'm tracing L, and I'm going to label it L. I'm going to get the ray AB right here, B and A. I also need the angle EFG, which I'm going to trace. Again, you might enjoy this more if you get more colors of Expo markers. I think I said before, Target has like an 8-pack for like $5. Okay, so there's everything's traced. I also want to trace my center. My center is O, so I'm going to put because remember I need to stay in the same place. And now I need to spin everything. So remember, O stays in the same place. Everything else moves. And because D is positive, we're spinning that way. So we're spinning this way. So remember, O is the only thing that stays. O is the center of rotation. So O is the same. That is the point. That is the center point. Everything else moves, but O does not move. And we're spinning counterclockwise because D is positive. And I think I'm going to stop like right there. You can spin however you want. You can stop here. You can stop anywhere. You can even, if you want, spin all the way around until some things run off of your paper. But I'll stop right here or close to there. Do you see how everything moved except the O? And you saw me rotate this way because D is positive. We spun this way. Now the only trick left is to copy this onto the paper so that you have evidence that you actually did the rotation. Now, one way to do it is to reach under the paper and try to put the dots where you need them. There is another way that I did show you in one of the last lessons where you can actually get a light and try to put the transparency under and try to see through the light. So I don't know if you can see that, where you can see my transparency through. I made a little helper object for me. It's like a little box. We'll see how it works. I have not used this before. So let me find O. Okay, so that's O. And my everything is on O. Now I'm going to try spinning and staying on O. So O stays and the transparency spins underneath. And then I try to find the objects. So O is on O. And then I can see, because the light's behind everything, I can see through. So there's C and D. I keep everything in the same location. So there's E, F, G. I still need to find, oh, there's line L. You have to kind of hold everything together, but there's line L. This is tricky. You do have to be precise. So there's line L. What else do I need? Oh, I need AB. Where'd AB? Oh, AB is over here. And I think that's everything. So you can see, let's see how good my paper worked. Get my flashlight out of the way. So, using a light underneath, and then how well did it follow? Not bad, not great, but not bad. Oh, there we go. That will be a little bit better. So AB I messed up a little bit on, but pretty good. I'm okay with that. It's close. It looks pretty close. Like I said, it does take practice. You figure out whatever method works for you. If you want to hold it up to a light, if you want to try writing under the transparency, just find a way that works for you. That's the way it works. I want it to be precise as you can get it. So whatever method you use that gets it precise, that's what I want you to do. Okay, let's go to page 45 now and get some more practice in. Number 6 says, let AB be a segment of length 4 units and angle CDE be a 45-degree angle. And let there be a rotation by D degrees, so we can pick the number, where D is less than 0. So D is less than 0, which means D is negative, which means we are going that direction. Always remember where your direction is. And the center is going to be, we're going to go about around O. So let's do this with our transparency. So let's label AB. Oh, well, let's start with O to make sure we stay in this. Let's do the center first. This is O. Then we'll do AB, making sure that O stays on O. AB. And we'll do angle CDE. So everything gets traced on our transparency. And now we're ready to rotate. Now remember, D is negative, so we're going to rotate clockwise. So we're going to spin everything this way. But remember, everything spins except the center. The center is O. So you can pick how far to move. I'm going to move about that far. That'll work for me. And now we need to write the images. So this time, instead of using my light, I'm just going to try to write underneath the transparency the best I can. Try to keep O in the same place. And that's going to be E. Keep O in the same place. And that's going to be about where C is. And this is going to be D, and then I need to label A and B, so I need to keep O in the same place. So there's A. And B is going to be about right there. So I did my points. Now I get my straight edge or ruler. I connect them to finish my rotation. There is B, there is A, and then C, D, E will look just like that. So that's my rotation. And so you see how that's what it was before. And then I rotated and O stayed in the same place. And then I don't know how many degrees that was, but it was a negative rotation, and that's where it lines up. Now yours will not look exactly the same because you might have picked a different degree, but it should look very close. Now let's answer the questions A and B for number 6. 6A, what is the length of AB prime? Well, A prime, B prime is going to be 4 units because the original was 4 units. And remember what I said at the very beginning of the lesson. A rotation is a rigid motion. Size and shape do not change. Size and shape do not change. And for part B, angle C prime, D prime, E prime is going to be 45 degrees because the original was 45 degrees, and rigid motions do not change size, do not change shape. Let's look at number 7. Let L1 and L2 be parallel lines. Let there be a rotation by D degrees, where D is bigger than negative 360 and smaller than 360 about around point O. So you can rotate this however you want. So they're saying you can rotate this however you want. So grab your transparency, and you're just going to take this. You're going to put your center. Center is O. And you need both your lines, line 2 and line 1. Close enough. Close enough. And these are parallel. The question is the prime lines still parallel? So look at this. Do they stay parallel when we rotate them? Does it matter how much we rotate? If I do a negative rotation like this, they are still parallel. If I start here and do a positive rotation like this, they are still parallel. So does the rotation change the parallel status? It does not change its parallel status. So what you say is yes. The rotations are still parallel. Because remember, rotations do not change size or shape. Number 8. Now, what happens if we only have one line? If we only have one line and we rotate it around O, so let's do, there's O on my transparency, and there's L on my transparency. If I have one line, will it be parallel? What happens if I rotate it like this? Is that parallel? No. Parallel? No. It is not parallel. Remember, because parallel means they will not intersect, and these keep intersecting. See where it intersects? See it intersects. all over here it's intersecting. The only time they will never intersect is if you rotate exactly 180 degrees. If you rotate exactly 180 degrees, they are parallel. But everything else, they intersect. So you see if I make this line keep going, it will hit the original. So they will always intersect, except if they're 180 degrees. And the question told us D cannot be 180 degrees. So are they parallel? No, not parallel. They will intersect, except if it's 180 degrees. So that's the work today. Hopefully you had a little bit of practice rotating with the transparency and labeling things. It was hopefully you see it as a challenge and make it super fun. There's a lesson summary on page 47 that you can look at just to remind yourself of the topics. Some of the details and the rules we discussed. Your exit ticket is on page 49, and this is what you're going to turn in, but that's the last thing you're going to do, so I would take this and slide it to the back of the packet. The homework helper is another example, so you can go through that if you're having a little bit more trouble. The problem set on page 53, I would like you to try yourself, and I will put the answers to this online. So try page 53, the problem set on your own, and check your answers with mine in the Google Classroom link. So the answers will be linked on Google Classroom. Check your answers for the problem set. When you're done practicing with the problem set, now's the time for page 49, the exit ticket, except the exit ticket answers will not be put online. I want you to try the exit ticket after you've done the problem set so that I can check the exit ticket myself. So the problem set answers I want you to do next. The answers will be online. When you're done with the problem set and you are sure you know what to do, give the exit ticket a shot. Remember to take a picture of your exit ticket and turn it into the Google Classroom so that I can grade it. Have fun working with this. Have fun playing with your transparency. And I will see you for our next math lesson.